now in this video, we're going to take a quick look at the full wave bridge rectifier. And so, in most real life applications, you have the household power, in which you have alternating current, which means the voltage of the two terminals keeps changing. But most of our electronics that we use, they need current to go one way, and voltage. So they also have capacitors and other stuff to make it work, but somewhere early on in the line, you need to make sure that one side is always more positive. So if that's more positive, that's more negative, you can see that diode will let current flow that way. If that's more positive, that's more negative, you can see current can flow that way, but not that way. Of course, it also has to go through the load and then the other diode right there. So that's the full wave bridge rectifier. You can see if that's more positive, current can flow that way. If that's more positive, current can flow that way. Main takeaway is that this terminal will always be more positive and that one will always be more negative, no matter the side that the supply is on. So I have here on the breadboard a more breadboard friendly version, and I meant to take the load off. But in any case, there you can see that I declare that this jumper here is always more positive. That one's always more negative, no matter which side of the supply is more positive and negative. So you can see here we have the anode to the rail there, the red jumper or red row, and then we have the anode to the blue row there. So when that's more positive, that's more negative, current can flow that way. Same with if that's more positive, that's more negative, current can flow that way. Down here we have the opposite. Hopefully you can see the gray stripe right there. So that'll let current flow when that's more negative. We're going to work positive and negative. And this one also will flow when that's more negative, going positive and negative. So that will be more negative. So let's do a quick demonstration. But hopefully that all made sense right there. So now we have an LED on the board. So just like the rectifier diodes, the LED is a type of diode. I'll move this over so it doesn't look like it's plugged into the same spot as the rectifier diode. So just like the rectifier diodes, it only lets current flow through in one direction. So we can quickly demonstrate that right now, and I just plug the red right there. Power supply is on. We're working with 5 volts. Now remember, the rectifier diodes, they drop about 0.7 volts each. So we're losing about 1.4 volts from the circuit. We're not going to see that right now because we're powering the LED directly. But there you can see, that's the normal way to power it. Because of the direction we put the LED. Now if we come down here, there you can see the LED is not going to light up. And in fact, that was a bad idea. I just short-circuited stuff. So don't do that test, actually, from now on. So, in any case, now what we're going to do is, that's why you get a current limiting power supply, and you also make sure you're more careful that you don't short-circuit things. So let's put it in the right way here. So negative to the blue rail, positive to the red rail, and there you can see that the LED lights up. Now if we put negative to the red rail, we also had less current than when we powered it directly, except for when we short-circuited, of course. And there you can see that even though the positive is to the blue rail and the negative is to the red rail, the LED lit up exactly the same as it would before. So if the voltage is changing also, and you need a steady voltage across the LED, then you need a capacitor over the entire thing to hold a voltage for a period of time while it's rapidly changing back and forth. So again, all topics for different videos. But in any case, this was the quick version of the rectifier, full wave bridge rectifier right there. So there were earlier circuits where you just had one diode that let current go one way, and then when the voltage changed direction, it just stopped out current, and it wasted a lot of energy and stuff. That was back when diodes cost more, and so you know, now it's really common. You can buy a component that does all this for you, individual component, and so you'll hear about halfway bridge rectifier or whatever they're called. But really, this is all you deal with now, the full wave bridge rectifier right there. So hopefully that all made sense. Make sure you check out one of the other videos that I'm posting. Click like, subscribe, the bell, all that. Donate to Patreon if you can. I put a link in the description. That would help out a ton. I will see ya in the next video.